76. Two strings of the same length and under the same tension give notes or frequencies in the ratio 4:1. Two strings of the same length and under the same tension give notes or frequencies in the ratio 4:1. The masses of the strings are in the corresponding ratio of 1. Okay, let's take a look at how that works. Alright, let's have the for string. The equation of frequency is what? F equals to 1/2L square root of what? Tension over what? Specific mass, specific length rather. That is mass per unit length. We call it specific length. So this, since we have two nodes under the same tension, listen, they have the same length and they are under the same tension. What does it mean? It means forget this. Since they are the same, it's constant. The tension is also what? Constant. So I say F is now a function of what? Square root of what? 1/mu. 1/mu is what? Is the specific mass of the substance, which is mass per unit length. So I can rewrite this as what? F equals to square root of 1/mass over length, because this one is mass per unit length and we call it specific length, and it means that what? My F becomes square root of L over M. However, we can go again and look at the question. It says the masses of the string, so we are more interested in the masses of the string. So what do? We strike out the what? The length. Don't forget, the questions told us it was of the same length. So anything that is the same, we assume they are going to be what? Constant. And visually we're going to say square root of what? 1/m. So for the two strings, you're going to say F1 equals to 1/m1 under square root, and F2 equals to what? 1/m2 under square root. Now these are my guiding equation. Now let's take the ratio. Since the ratio of their frequencies is 4:1, it means that what? It means F1 all over F2 is equals to what? 4 all over 1. But from here, if we do that, we're going to see it as what? Square root 1/m1 all over square root 1/m2. Just from these two equations, and definitely we can say that 4/1 is the same thing as what? Square root of m2 all over m1. And if you square both sides, what happens? The square root of this one will cancel, this one becomes what? A square. So 4 squared all over 1 is going to be what? M2 all over M1. And what is 4 squared? 16 all over 1 equals to M2 all over M1. However, our ratio would have expected an answer that has to do with what? 16:1. No, it can't be 16:1 because originally it was F1 to F2. Now you are getting M2 to M1. It should be the word corresponding ratio has to take you back on track. It means that what? My M1 all over M2 is simply going to be what? 1 to 16. So that gives me what? Option D as the correct option for that question. Next. So let's go for question 77. To obtain a magnification of 2.5, how far should an object be placed from the pole of a thin converging length of focal length 10.20 meter? This is another length problem, and we already are given that the focal length. We are given the magnification, and the magnification is 2.5. M equals 2.5. And an object is placed from the pole, that is, we are looking for what? Image distance, object distance. And we were told that what? The focal length is what? Is 10.20 meter. Since it is a converging length, the focal length of a converging length is always positive. So we don't have to change this to a negative value, and we use our magnification formula, image distance over object distance. With that, we have m, which is 2.5, equals to v over u. If you cross multiply, you're going to have what? V equals to 2.5 u. And with this, we can begin to put in our what? Our length formula. So 1 over f equals 1 over u plus 1 over v. So our 1 over f is 1 over 10.2 equals to 1 over u plus, instead of writing 1 over v, since we have said that v from magnification is 2.5 of u, so we're going to write what? 2.5 u. Here we sub this right hand side, and what are we left with? The sm is obviously 2.5 u, and u goes there, it will give you 2.5. This goes there, it will give you 1, and this is going to be 3.5 over 2.5 u equals to what? Equals to 1 over f, or rather 1 over 10.2, since our f is 10.2. So 1 over 10.2 equals to 3.5 over 2.5 u. We cross multiply. So 2.5 u equals to 3 times 3.5 times 10.2, and we have 35.7. So we divide both sides by 2.5 so that u becomes 35.7 divided by 2.5. With this, you're going to get u as being equals to 35.7 divided by 2.5, and our answer is just 14.28 meter, meter, and that is option C. So option C is the correct option for question 77. Next. Alright, the diagram above shows two waveforms x and y. If the frequency is 30 Hz, what is the frequency? If the frequency of x is 30 Hz, what is the frequency of y? So we have the diagram. So for clarity, I will draw the diagram again and see how we can solve this if we have a question like this. So we have a waveform. We have a waveform, and there are two traveling waves. These are x, and what happens? We have y, and this is what? Y. Let's put the y here and y here. However, it is not that bold, so I can make it broken so that it looks imaginary. Alright, now when we look at this, there is a kind of interference that actually happens between what? X and y. Let's look at their source. They pick up at the same point, and they are actually interfering at this point, Then there is a relationship between what? X and y. Let's now try to establish such a relationship. The question says the frequency of x is what? 30 Hz. Frequency of x equals to 30 Hz. And don't forget, by definition, we say frequency is reciprocal of what? Of period. Is reciprocal of period. Definitely I can say T equals to 1 over F, which is what? 1 over 30, and this is what? 0.3033, and that is going to be what? Seconds. That is the period. So we have the period of what? Of x. So period of x, we have it to be what? 0.033 seconds. If the period of x is 0.033 seconds, what does period say? It is the time taken for a complete oscillation. Meaning, for x to travel from here down to this place, that is a complete oscillation, it took x 0.033 s. However, we ask ourselves, within this time period, how many times does y travel, or how many circles did y complete when x completed a circle? You can take a look at this. This is the first circle and the second circle. It means it will take y 2 circles to complete what? To complete 0.033 seconds. For one circle, if it will take, because it is at the same time on the axis, so if it will take y, if it will take y 1 over 0.033 seconds, all by what? All by 2 to complete a cycle. So why do I have to say divided by 2? Because it completed 2 circles within this time period. You can see the first circle, the second circle. So we say definitely if it took y the same period, which is 0.033 seconds, to complete 2 circles, then to complete a circle, it will take it half the time it took y, it took x rather. Then we can say definitely the period of y is same thing as what? As 0.0167 seconds. That is the period of what? That's the period of y. However, the question did not ask us for period, it asked us for what? For frequency. We go back again. Don't forget I said that frequency of y will now become what? 1 over period of y. That is equals to 1 over 0.0167 hertz. And this is going to be frequency of y equals 1 over 0.0167 hertz. And this is what? 60 hertz. That is the answer for that. So the correct option is option C, which is what? 60 hertz. Next question. Question 79. Which of the following eye defects can be corrected by cylindrical lenses? Which of the following eye defects can be corrected by cylindrical lenses? A. Presbyopia. B. Chromatic aberration. C. Myopia. D. Astigmatism. It is actually astigmatism. What is astigmatism? It's a defect of the eye that makes the what? The eyeball or the lenses of the eye to look what? Instead of being spherical, it bulges as if it is an oval, or it looks like what? A rugby ball. And in that case, the eye cannot what? The rate at which the eye see any objects in front of an eye will be what? We appear to be bulged. And as such, to correct that, we use what? Cylindrical lenses. Next. Question 80. A spectrum of sunlight is said to be impure when A. It is made of only 3 colors. B. It has no red color in it. C. The different colors in it overlap. D. It does not contain white light. We all know that what? A white light is what? Is a polychromatic light, meaning it has other lights of what? Of different wavelengths imposed or coming together to form that white light. However, we call it an impure spectrum whenever there is what? An overlapping. Whenever there is overlapping of different colors, that is when we say it is what? An impure spectrum. So the correct option is C. The different colors in it overlap, that's when it is what? Impure. Next. 81. A cell of internal resistance 2 ohms supplies current to a 6 ohm resistor. The efficiency of the cell is what? So we have cells. So we have a cell of internal resistance 2 ohms. So internal resistance of the cell, that small letter R, is what? 2 ohms. That is 2 ohms. And it supplies current to 6 ohms. So that is external resistor, capital letter R, and that is what? 6 ohms. So the efficiency of the cell, don't forget that when the internal resistance of the cell is going to inadvertently affect what? It is going to affect the efficiency of the cell. So we always want to have a cell with no internal resistance or very little internal resistance. So the efficiency of cell will be what? Internal resistance, or let me say small letter R, over external resistance times what? 100%. That's another way, because the internal resistance is going to lead to what? To energy loss, and this is going to be 2 by 6 all by 100%. So let's take a look at this and see what happens. 2 by 6, and this is going to be what? 33.3%. So the answer is what? 33.3%. That is what? The efficiency of the cell. Next question. A particle is injected perpendicularly into an electric field. It travels along a curved path as depicted in the figure above. The particle is what? Now we have an electric field and there is a particle that travels into the field. Alright, you all know how an electric field behaves. It behaves very similar way with what? With a magnetic field. Now we have some point charges and we have the field created. So there is an arrow that points up, and there is there is a particle that was sent into this. However, when it goes to this line, it got deflected, and you can see the motion became what? Became deflected. And in such a way, the arrow comes this way. However, we need to know the charge here. Because the arrow is moving up, it means that what? There is a positive charge here and there is a negative charge here. So this is a positive charge down, this is a negative charge here, up. Because the direction of a point charge is such that it moves from the positive to the negative. So we say definitely this body, for it to be deflected towards the positive, it must be a negative particle. If it had gone up, then it would have been a what? A positive particle. Because by electrostatic, like charges we what? We repel, and like charges we what? We attract. So let's look at this. A gamma ray. Gamma ray is out of the equation because gamma ray has no what? Has no charge. And as a matter of fact, when you subject gamma ray into an electric field or a magnetic field, it isn't going to do what? It isn't going to deflect. B, an electron. An electron is negatively charged, so it's possible it is an electron. However, let's go and look at other options. A neutron has no charge. B, a proton is positively charged and it will never deflect towards the positive side. So the correct option is an electron. B is the correct option. Next. 83. A thin film of liquid is trapped between two glass plates. The force required to pull the plates apart will increase if the what? A, surface tension of the liquid is reduced. B, perpendicular distance between the plates is increased. C, area area of the liquid surface in contact with the plate is increased. D, pressure of the air is decreased. And you just take a look at a case where what a thin film of liquid is trapped between two glasses, and you want to do what? The first you want to separate it. It is going to what? It's going to increase if you actually do what? If you actually increase the area of the liquid surface in contact of the plate with the plates. That is simply because if you increase the area, it means that what? Don't forget, force pressure is force over area, and force equals what? Pressure times area. There is an inherent pressure in these two surfaces in contact, and whenever you increase what? The area of the liquid, you are going to increase what? The pressure, the force is required to put them apart. So the correct option here is what? Is C. Next, question 84. From the kinetic theory of gases, temperature is what? We all know this is a very statement. Is a statement that you must have learned from your first classes you had in your senior secondary school. And this is just a kinetic theory of what? Of matter. And it says what? Temperature is a measure of the average kinetic energy of a particle. If a particle gains temperature, then its kinetic energy is increased. All right, let's take a look at the question again. From the kinetic theory of gases, temperature is what? A form of energy, and is proportional to the total kinetic energy of the molecule. It didn't say temperature is a form of energy. However, heat is a form of energy. It's only temperature is never a form of energy. Temperature is just a measure of what? Of the degree of coldness or hotness of a body. So it is not a form of energy, and kinetic theory will never tell us that. B, form of energy. It is not a form of energy. So any option that has to do with form of energy, you have to remove it out of the possible or likely options. C, physical property. Yes, temperature is a physical property, and it's proportional to the total kinetic energy of the what? Of the molecule. It did not say it is proportional to total kinetic energy. It says it is proportional to the what? Average kinetic energy of the particle. So it's not the total kinetic energy. So that option is also going to be ruled out. The last option there is D, physical property, and is proportional to the average energy of the molecule. That is the correct option. So the correct option here is going to be D for question 84. Next, dispersion of light by a glass prism can be reversed by, if you want to reverse the dispersion of light, you don't want the constraint of white light to be separated again, you want them to be recombined together. What do? A, reversing the direction of the light? No. B, another prism is placed upright beside the first prism? No. C, another prism which is inverted and placed side by side with the first prism? Yes. If you do this, you need to recombine the what is just, you are reversing the first process of dispersion, you recombine it, and you are going to have what? A white light. B, placing glass beside the prism. And you cannot place a glass beside the prism and expect the white light to recombine. No. So the correct option for question 85 is C. Next, 86. Two insulated charge spheres of different sizes are carrying opposite charges are connected together by a metallic conductor. Current will flow from one sphere to the other until both spheres, when you have two insulated charge spheres of different sizes and carry opposite charges, and they are connected together by a metallic conductor, what happens? Current will flow only when their potentials are equal. When their potentials are equal, that's when currents will now flow. All right. So A, carry the same magnitude and sign of charge. B, are the same potential. C, are the same temperature. D, are of the same size. So the correct option is what? Are of the same potential. Next, 87. When a number of identical small magnets are arranged in a line, the strength of the resultant magnet A is largest when they are arranged end to end. B is greatest when they are arranged parallel with light poles adjacent to each other. C depends only on the number of magnets provided they are parallel. B is greater when the magnets are arranged on the wooden surface. The correct option is what? Is A. It is largest when they are arranged end to end, because it's going to be a kind of what? A kind of resultant forces. Mind you, at each of these poles is a what? Is a force that is strongest at what? At the poles of each of these magnets. So when you arrange them end to end, you're actually increasing the what? The resultant force, or the resultant magnetic force you get from there. Next. So 88, a bar magnet is most effectively demagnetized by, you can demagnetize magnets by different methods. You can demagnetize a magnet by hammering it. You can demagnetize a magnet by taking it through a temperature. As a matter of fact, no magnet will withstand its magnetic property at a temperature known as what? Curie temperature. Curie temperature is about 5,000 degrees Celsius, and anything you heat up to this temperature is not going to retain its what? Its magnetic property. That's another way of what? Of demagnetizing a magnet. And you can also put it in a what? In a coil of, in a solenoid, and withdraw it gently from the solenoid in the east-west direction. East-west direction. Take note of that. So to demagnetize, you place that magnetic substance in the what? In a solenoid, and you withdraw it over a long distance in what? In the east-west direction. Let's take a look at the options. A. Placing it in a northeast position and hitting it with a hammer. No, you don't place it in a northeast position, and that will not demagnetize the magnets. B. Subjecting it to an electric current from a battery. No, that will not do that. C. Bringing its north pole in contact with the north pole of a very strong magnet. That will just result into what? A repulsion. It's not going to what? Demagnetize the magnet. B. Hitting the what? Hitting the magnet. If you hit a magnet, like I told you, it is the most effective way of demagnetizing a magnet. No strong magnet will be heated up to a Curie temperature of about 5,000 degrees Celsius without it losing its what? Its magnetic property. And that is the correct option. D is the correct option for 88. Next. 89. Shadows and eclipse result from the, I have said that in one of the questions we solved before now. So what? When you are thinking of what? Rectilinear propagation of light, we usually use shadows and eclipse to explain the rectilinear propagation of light. And what is rectilinear propagation again? Let me bring you back to the memory lane. That I told you that rectilinear propagation of light is what? Is the phenomenon in which light travels through a straight line. And that's, let's take a look at this. Refraction of light, no. B. Rectilinear propagation of light, that's just the correct option. So that's B is the correct option for 89. Next. Which of the following is associated with alternating current only? Which of the following is associated to alternative current only? A. Transformer. B. Lead acid accumulator. C. Induction coil. D. Transformer. Oh, we have two transformers there, and maybe the examiner wants us to be sure if we're actually going to choose transformer. However, we'll do justice by looking at all the options and analyzing them, their relationship with either AC or DC. Let's take a look at the transformer. A transformer is a what? Is a device that takes in AC. You don't transform a DC source. You only transform a what? An AC source. Because transformer works on the principle of what? Electromagnetic induction. It works on principle of electromagnetic induction, and there will be no resonating frequency in DC. That is why DCs are generally not what? Transformed. However, there is only a way to design a transformer, and it will work for what? It will work for a DC. This was done by a scientist popularly known as what? Rumcock, and he calls the transformer induction coil. This time around, it's not going to work on what? On AC. It's going to take in what? DC. And generally, they are used what? In the starter kit or starter of most automobiles, they use that, especially the gasoline automobile. So the induction coil is the DC version of the transformer. If you hear the word transformer is for AC, if the induction coil is for what, is for DC. Lead acid accumulator, accumulator does not have anything to do with what, with AC. It's what is giving you is what, is a DC current. So the correct option is what, transformer, either A or D. Next. 91. Calculate the distance between point X and Y with coordinates 3, 5 and 7, 9 respectively. So we have to look for what, distance when we're given points. However, we need to know that this 3, 5 means what, X, Y. So the X is what, X1, Y1, X2, Y2. X1 is what, is 3, Y1 is 5, X2 is 7, Y2 is what, 9. And here the distance between X and Y is given by the formula, open bracket, X2 minus X1 all squared plus Y2 minus Y1 all squared. And here we can do justice to it by putting in our values. And this is just going to be what, X2, which is 7, minus X1, which is 3 all squared, plus Y2, which is 9, minus Y1, which is 5 all squared. And what are we left with? We are left with 4 squared here plus what, plus another 4 squared here. And this is what, square root of what, 16 plus 16, and this is what, square root of 32. And we can see we have no square root of 32, so we have to break it down into something root of something. So you can see that if you take 32, this same root 32 can be said to be root of what, 16 times 2, and at that we have root of 16 is 4 and root of 2 remains 2, so units. So that is our option is 4 root 2 units, and that is our answer. Option B is our answer. 4 root 2 is the answer as to the distance between X and Y. Next. 92. The types of motion exhibited by a drum rolling steadily down an inclined plane are. Now, when a drum rolls steadily down an inclined plane, the words used in these questions are very important, and we need to understand the words used in the question before we can do what? We can know what the question is actually talking about. Alright, it says the type of motion exhibited. We know we have a lot of different types of what? Of motion. By a drum rolling steadily, the word steadily, the word only means what? We have rotational motion, but the word steadily means what? The drum is not going to vibrate along its way down the inclined plane. And having gone through the rotational motion on the inclined plane is obviously going to cover a distance that we can call translational. So it is both rotational and translational. The fact that the word steadily was used means we should zero our mind from considering oscillatory or vibratory motion to be undergone by the what? By the drum. So the correct option is going to be what? Rotational and what? Translational. And I think we have that. So D rather. Question 93. One of the advantages of friction is that it A. causes wear and tear in machines, B. increases the efficiency of machine, C. increases the motion of an object, D. makes car tires to have firm grip on the road, E. produces heat in engine. It is what? Is that it makes car tires to have firm grip on the road. If not because of friction, we wouldn't even be work as human beings, talk less of cars. So it is because of friction that car tires were able to do what? To firmly hold grip the road. D is the correct option for question 93. Next, question 94. A car traveled with an average speed of 120 km/h for 30 minutes. Calculate the distance covered by the car. Now we first look at our options before we know how to approach this problem, because our options all are in what? Kilometers. We don't need to convert to meters, so we just use the kilometer as our what? As our standard here. So let's take a look at the parameters given to us. So we have a car with an average speed of, so average speed is average speed equals 120 kilometer per hour, and you do that for time t. Time equals to 30 minutes. Now because of the per hour, we cannot use 30 minutes with hour, so we have to do what? We have to change the 30 minutes to what? 30 minutes to hour, to hour. How we know that 1 hour is what? 60 minutes. So if we have 30 minutes, it means that what? Time will be what? 30 over 60 hour, and this is what? This is 0.5 hour. This is what we can use. And don't forget, distance is what? Distance is average speed times time. So we are going to have what? 120 times 0.5 all in kilometer, and this is simply what? 60 kilometer. So the correct option is option C, 60 kilometer. Next, 95. We have some graphs, and these graphs, we have the first graph that looks like, let me replicate the graphs for better visibility, and you have the first one, and it's just down here. You have the second one, and just goes and comes down. The next one, and it goes down here, it comes down, and last, okay, we still have another one, and it is just like this, and last but not the least is what? Is this one that comes like this. Alright, the following are the graphs that you have, and the question is asking for this are velocity time graph, time, velocity time, velocity time, velocity and time, and the question is asking in which of the velocity time graph below is the acceleration non-uniform. Alright, let's see how it works. Here you see that the acceleration here is uniformly accelerated and then decelerated. However, this is what? Deceleration. There is an acceleration here, there is a deceleration here. Here it is a constant speed, then deceleration. Here it is what? An acceleration, but it is what? It is not constant, because it's a curve. If it were to be a straight line, it would have been considered what? A constant acceleration. Here it is simply what? A deceleration. So to choose the option here is simple, but you have to be what? You have to be very careful, because you might likely fall, a prey to logic in this logic reasoning in this kind of question. So here is deceleration, but the question says acceleration. So this is out of it. Option A cannot be. The option B is both acceleration and deceleration, so it can never be. Option C is deceleration, it can never be. Option D is an acceleration, but this time around it is not uniform. So the best option or the correct option is what? Option D. Next, 96. Which of the following pairs of quantities are both vectors? We have said that vector quantities are quantities that have both magnitude and direction. Let's see. Displacement is a vector quantity, however, density is not a vector quantity. So we want the one that are both what? Vector quantity. Energy is never a vector quantity, however, momentum is a vector quantity. Power is not a vector quantity, however, force is a vector quantity. Volume is not a vector quantity, however, velocity is a vector quantity. And we look at the last option, weight and acceleration are both what? Vector quantities. So the correct option is option E. Question 96. Option is what? E. Next. 97. A body immersed in liquid will float when it displaces volume of the liquid equals to, if it floats according to the principle of flotation, then it has displaced the volume of liquid that is equal its own what? Its own weight. So the first option says equal to a quarter of its weight. No, B equals to its own weight. That is the correct option. That is B. Next. 98. A ball is thrown with an initial velocity of 35 meters per second at an angle of 20 degrees to the horizontal. Calculate the horizontal distance covered by the what? By the ball, given that acceleration to gravity is 10 meters per second square. So what is another name for the what? Horizontal distance covered by a projectile motion? We call it what? Range. So it is what? Range. Let's see. There is a formula for range, and we say R equals to what? U square sine 2 theta all over G. That is the formula for what? For range of a projectile. And we say R equals U is 35 square sine 2 into 20 degrees all over 10. And here I am going to have and that is 78.74 meter. 78.74 meter is my correct option. That is option D. Next. 99. The relative density bottle weighs 0 kg when empty, 0.1 kg when filled with water, and 0.2 kg when filled with a liquid. Determine the relative density of the liquid. However, we know that relative density is what? Weight of liquid over weight of water. That is relative density. So we say it is going to be relative density equals to weight, or we can say mass. Let's use mass because the parameters given to us is mass. So mass in fluid over mass of water, equal volume of water. Moreover, mass of fluid over mass of equal volume of water. And when you check that, it gave us 0.10 all over 0.20, because kilogram we cancel kilogram, and don't forget that of water is 0.10 and the other one is 0.20, so it is 0.20 and what? 0.10, and this will give what? 2. So the relative density of the liquid is 2. So the correct option is option B. Next. Question 100. A body performs simple harmonic motion at a frequency of 60 Hz and an amplitude of 2 centimeters. Calculate its acceleration at the end of the path of oscillation. So this is a problem that we can just write out our parameters. However, we know that when the question has to do with acceleration is what? Is omega squared A, where omega is what? Is angular velocity. So what is angular velocity? It is what? 2 pi f all squared times your amplitude. That is, if we multiply our amplitude by our omega square, we need to get acceleration. We're given frequency f equals to 60 Hz and amplitude capital letter A equals to 2 centimeters. However, we cannot use 2 centimeters, we have to convert to meter. This becomes 0.02 meter. We divide centimeter by 100 to convert to meter. Calculate its acceleration at the end of the oscillation. Don't forget that we only need frequency and amplitude to get acceleration. So acceleration is going to be omega squared, that is 2 pi times frequency 60 all squared times 0.0210 meter per second square. When you do this, super, and this is what? This is 2.84 times 10 raised to power 3 meter per second square. That is the acceleration, and the correct option is going to be C.